Okay, so for 10-7, we're doing area. The way I remember and differentiate area and circumference, area has a square in the formula, because think about the units. If I'm in inches, what are the units for area? Inches squared. Right. So your units are going to be matching your formula. If you're in the area land, it's radius squared. If you're finding just a circumference, then there is no square, and it's either 2 pi r or pi times the diameter. So in this section, we are only focusing on area. So the area of a circle is pi times the radius squared. Do not be fooled by the diameter. If they give you a diameter, which they indicate, this little Pokemon ball, you're welcome, which they indicate by drawing a line all the way across the circle, that's the diameter. If the line was only halfway across, it would be a radius. So this line goes all the way across, so it's a diameter. So the radius is half of that 10 inches. Then we just plug it into the formula. Area equals pi times the radius squared. So area equals 25 pi inches squared. Most of the time, like on your standardized test, which for my 11th graders is next week, we are going to be leaving the pi in the answers. So if you look at the first few answers to the practice assignment, there's a pi, there's a pi, there's a pi, there's a pi, and there's a pi. Leave the pi in the answer. So you got to read the instructions carefully. If the instructions tell you to leave your answer in pi, you don't multiply the pi through. You just do everything else. Like, I can find 5 squared on my calculator if you really want to. Like, you just don't want to engage your brain today. But don't multiply it by the pi. Dylan, do you have a question?
No.
Okay. All right, so that's the area of a circle. We do that in 6th grade and up. So that should all be kind of a review. The thing that we're going to do different is we are not going to find the area of the entire circle, but we're just going to find pieces, area of sectors of the circle. So to find the area of just a piece of the circle, we take our arc measure, divide it by 360, then we multiply it by the area of the circle. So just like we were doing little pieces of the circumference last week, this is the same concept. We're just going to find the arc length of our sector, and remember that's the same as the measure of the central angle. So if it tells you 80, that is the number we use for the formula. So for example 2, we're going to go 80 divided by 360. Then we're going to times it by the area of the whole circle. Remember, halfway across the circle is the radius, all the way across the circle is the diameter. So 4 feet is the radius. Now, if I were to do this in my calculator, I would do everything except the pi. I'd go 80 divided by 360 times 4 squared. Let me do that one more time. 80 divided by 360. And we look kind of decimally. So let's see if we can reduce it down. Sometimes it's not decimally, like on some of these problems, it won't be so much of a decimal. So let's see if we can reduce it down. We can already get rid of the 0 and the 0 because it's like dividing by 10. 4 goes into 8 twice, and 4 goes into 36 9 times. 4 squared is 16, and we just leave the pi on the end. 2 times 16 is 32. And the pi hangs on, and it is in feet squared. If we were to do this in our calculator to find an approximation, because sometimes we do that, we go 32 divided by 9 times pi. So it's about approximately equal to 11.2 square feet. You guys have to be comfortable doing both. When you go to take the SAT or ACT, they're going to give, sometimes they're going to multiply it all out. And then, or your college math placement exams, sometimes they're going to have you multiply everything out. Sometimes the multiple choice answers will leave the pi in there just to see if you guys know how to reduce. So be comfortable doing it either way. All right. For B, they already give us the arc length, so we don't have to find it from the central angle. So the area is 24 degrees divided by 360 degrees times the area of the circle, which is pi, times 14 squared. Sometimes you roll the dice and win. So let's go 24 divided by 360 times 14 squared. Oh, it's a decimal. Okay. So let's reduce it. Because I've done this problem before, I know 24 goes into 360 15 times. I only know because I cut it in half, and then I cut it in half again, then I cut it in half again, and then I was like, oh yeah, that's back there. So 24 divided by 360 is 1 over 15. 14 squared is 196, only because I have that memorized. So we're going to mush that together. I know I have 14 squared memorized. What are you going to do? And the area is equal to 196 pi divided by 15. And if you chug that in your calculator, it is 41.1 units squared. Okay. Now that we feel confident with area of a sector, we are going to go even further and find the area of a segment. So if you look, we can take this sector and draw a line. It's actually technically called a chord. Draw a line from where it touches the circle in one place to where it touches the circle in the other. When we do that, we get a triangle. And if we were to subtract out the area of that triangle, we find the area of this roundish segment of our circle. So what we're going to do is we're going to find the area of the sector using the formula we just learned, minus the area of the triangle. We know the formula for the area of the triangle. It's 1/2 base times height. And we know how to use either special right triangles or trigonometry to find the base or the height of those triangles. So we're going to take a little peek at this circle right here. Its radius is 18. So the radius from C to A is still 18. Radius stays the same all the way around the circle. So you can, I just put it on there so we can see how that translates. Our central angle is 60. So if I'm finding the area of the sector, I'm going 60 divided by 360 times pi r squared. Third time's the charm, right? Third time's the charm. 60 divided by 360 times 18 squared. It's 54, yay, it finally worked. So this is the area of my sector is 54 pi. That's this whole thing right here. Everything inside. Now I have to find the area of that triangle. So what I'm going to do is I'm going to redraw the triangle. I'm going to put my 60 degrees at the top. This is 18. Technically so is that, but I'm not going to. Because it's a 60, and this is isosceles, this is also 18. The area of my triangle is 1/2 base times height. I already know the base. It's 18 because I have an equilateral triangle. How do I know I have an equilateral triangle? Pause so you guys can think about it. So because this is an equilateral triangle, because the top is 60, the sides were 18, isosceles triangle says I need 120 to split up for my base angle. 120 divided by 2 is 60 and 60. So now I can use my special right triangle to find the height of the triangle I want to find the area of. 30, 60, 90 triangle says whatever my small side is, my hypotenuse is double that. My short side is a small side times √3. Look at our picture here. This guy is 9, so our short side for our triangle here is 9. Hypotenuse is twice as big, it's 18. So what does that leave for the height of our triangle?
9 squared.
Yeah, it's going to be 9√3. So we got 1/2 times the base times the height. Half of 18 is 9. 9 times 9 is 81. So the area of my triangle is 81√3. So we're going to go 54 pi minus 81√3. The reason we don't round up here and we don't round here is because the more times we round it, the further away from the real answer we get. So my suggestion is you keep it in irrational terms. Pi is an irrational number. √3 is also an irrational number. So unless you feel like writing every single decimal from your calculator that this gives you out, which is just easier to write pi than to write all those decimals, keep it in irrational form. At the very end, put it in your calculator. 54 times pi minus 81 times the square root of 3. 29.3 approximately. If they wanted you to leave it in terms of pi, you would stop right here. You would stop. When you guys move on to Algebra 2, whether it's advanced or regular, there will be some tests and pre-calculus. There will be some tests you won't be allowed to use your calculator on. In those scenarios, you will have to keep it in this form with pi's in it and stuff, because they won't have you multiply it out. Okay, that's the end.